Right, hello year 13 or year 12. Now these types of exam questions should be bankers. Now let me give you a little bit of a tip. It's in the title, but do not confuse constant acceleration with variable acceleration. With constant acceleration you use SUVAP. Now you know it's variable acceleration straight away because you've got velocity and it changes as time changes, t here, and obviously t is greater than 0. So it says find the initial velocity of the body. Now that's straightforward. Initial velocity must be when time t equals 0. So let's write t equals 0. We get a method for trying to just substitute that in. So all we're doing is v equals minus a third, 2 times 0 squared, minus 9 times 0, minus 18, and chain yourself, substituting that in, get your method mark, and you can see that minus a third times minus 18 is going to give you 6 meters per second. That's quite easily done. Now for part B, it says find the value of t when the body is instantaneously at rest. Right, so we know when it's at rest, the velocity is not moving, so v must equal 0. So if you show this line here, you get a method mark straight away. Now if we multiply both sides by 3 to make it easier to handle, because 0 times 3 is 0, so we just set 0 equals 2t squared minus 9t minus 18. Now we should be good at factorising this to solve, so this is just GCSE skills really. So that's 2t, and we're going to get a plus 3 and a t minus 6. We know t is greater than 0 or equal to 0, so it's clear to see that the answer is t equals 6, and that is quite easily solved. Now, doing this bit gets you another method mark, and that gets you your answer. That's an easy 3 marks as well. C. Now find the greatest speed of the body in the first 7 seconds of motion. The greatest speed. So you need to remember, how can we find max or minimum values using these skills here? Right, well, if you just state t equals 0, v equals 6, that actually gets you a method mark. Now we need to differentiate v equals minus a third 2t squared minus 9t minus 18, because if you remember, that's like us doing a second derivative. I know that, and this actually is going to be acceleration when you do this, but that's just a fact. So if we differentiate that, what do we get? So first, and lots of people seem to make a mistake on this, let's expand this out. So this would be minus, let's write it here, v equals minus 2 over 3 t squared, minus times a minus is plus, that's plus 3t, and plus 6. So dv dt, like which is almost like doing a second derivative to find a maximum or minimum value, is going to be multiplied by the power, so that's minus 4 over 3t plus 3. Now remember, we set it to 0 and solve. Now can we remember, what do we need to do here? So we find t, so t is going to equal let's see, 4 over 3t is going to equal to 3. So times 3 divided by 4, t equals 9 over 4, which equals 2.25. So that value is going to give us a maximum and minimum value of v in the first 7 seconds of motion. So we just need to substitute this value, sub into v equals, because that's our formula for velocity, against time. So just substitute that value in correctly and you'll get v equals 75 over 8 meters per second, and that will give you an accuracy mark. That will be an accuracy mark. You've probably got a method here as well, and I believe in this question you get a mark for concluding statement. So you need to conclude that the greatest speed in the first 7 seconds is 75 over 8 meters per second, or you could round it to 9.375 as an exact answer, or just round it to 2 different figures, and that will give you your C1 mark. So that's an easy 5 out of 5. Just want to go over something here. If displacement is in meters, we know when you differentiate, we do things to the power goes down by 1. So that's why velocity is in meters per second to minus 1. We differentiate again, and the acceleration is meters per second to the minus 2. And that's the same how we integrate. It goes, we raise the power by 1, and hopefully that helps you remember what to do to get from displacement to velocity to acceleration. Right, do remember to pause this video at any point so that you can give the question a go yourself and look through the detailed solution. Now, you've got a particle P that moves in a straight line at time t seconds. The displacement S from a fixed point O, like the region, is given by this formula. So S is displacement, like x. Find the distance between the points at which the particle is instantaneously at rest. So let's think about in the constant, when in the context of this question, when it is at rest, that means the velocity is what? And if you said 0, that is correct. So this is going to be when v equals 0, right? But we've got displacement, so we can differentiate displacement. So ds dt, or dx dt in this instance, is actually going to give us the velocity. Okay, so how would I do that? So I'm going to start off with s equals, let's multiply this out, that's 8 over 6 t cubed minus 105 over 6 t squared plus 144 over 6t plus 540 over 6. Let's start off expanding that correctly so that we can easily differentiate this. So ds dt, remember that is we're going to get the velocity through that, so we're going to get times by the power, decrease the power by 1. So that's going to give us t squared. 8 times 3 is 24, divided by 6 is 4. So we're going to get 4t squared here. 105 times 2, 210 over 6. So that's going to give us minus 210 over 6t. Right, next, that's just going to be plus 144 over 6. And that's okay. We're not integrating, so there's no constant to be involved with. Now, how could you do this? You can use the quadratic formula to solve, or factorise. Whatever's easier for yourselves, but do show yourselves working it out. So remember, we want v equals 0, so we set that to 0. Now if you wanted to factorise, we could take the 1 out of 6 out of the bracket, get 40, that will be 2040 squared, to make that 40 squared. Now we can just get minus 210t plus 144. Now I would argue it's probably easier to use a quadratic formula than factorise this, but you know how to do that, so I'm not going to use the video to explain that. But you'll solve it to find t equals 0.75 and t equals 8. Okay, that actually gets you an accuracy mark. This will get you a method mark. Doing and setting that to 0 here, that's probably your method mark as well. Okay. Now, next stage. Find a distance between the points. Well, we've got time. What can we use the time in? We sub into this. We sub into this. So sub t equals 0.75 into the equation first. So you should get, do this on your calculator correctly. Okay, and you should get x equals 3159 over 32, or you can just write 98.71 rounded to 2 dp. Now obviously you will do the same for t equals 8. So Cherry's clearly sub t equals 8 into the question, and then you'll get s to equal minus 466 over 3, or minus 155.3. Now that might look confusing, but if there's a particle moving on a straight line, all that means is because you've got a negative minus 105 t squared here, at 0.575 seconds, 0.75 seconds, there's a point, that's our start O, that's 98.71 meters. Right, now at t equals 8 seconds, so what's happening is the particle is going like this, and you can see the formula for velocity, and after a certain time it goes this way along the region to the minus number, alright, at 8 seconds. So that's fine. So you have to find the distance between the 2 points. So that's actually from here to here. So you're just doing 155.3 add 98.71, and they will set 254 meters. And that question is not too bad if you think about it. It's just applying lots of skills that you know. So that's 1, 2, 3, 4. I believe you get a mark for substituting this one incorrectly. That's a method here, and that's your accuracy. So that could be an easy 7 out of 7. Hopefully that is clear to you now. Now this question, do pause the video and read the question whenever you're ready. I've highlighted the key terms. Now velocity time graph. So what we need to know is that is going to be v against t, and it does say sketch, so it doesn't need to be detailed. V against t. Now if we expand this out, we can see this is a cubic. Now you've got to think minus t times minus t, because obviously this is going to look like this, and 1 over 20t. That's going to give us a positive cubic, which we know is this shape. Now this is all the incomplete square form, so we can see t equals 5 is when v equals 0, and t equals 0 here, t equals 0, and v equals 0. So let's just do 0.5 seconds at 0. So we just know a sketch like this will be fine. Okay? And that's an easy 2 marks out of 2. Apologies about my phone going. Right, now let's look at the second part. Find the values of t and the corresponding values of v when the acceleration of p is instantly 0. So understand the wording of the question. So what are we talking about here? Now, what's the best way to approach this? Well, interestingly enough, in the mark scheme, it says when t equals 5, v equals 0, you get a method mark. That's actually, no, not a method mark, a B mark, which is actually an easy mark. Now you need to obviously expand these brackets out, right? So, depending on how you want to do this, let's write this like this, because people will make a mistake with the expanding otherwise. Okay, so I know this section is going to give us 25 minus 10t plus t squared and 1 over 20t. So that's going to equal 25 over 20, which is going to be 5 over 4, minus a half t squared plus 1 over 20 t cubed. Now it's talking about acceleration, right? So we know we've got v against time, so dv dt equals a, and we should instantly know we need to do that to earn some method marks, because it's talking about acceleration. So let's differentiate that. So that equals 5 over 4 minus t plus 3 over 20 t squared. Okay, and that gets you another method mark. Right. When the acceleration p is instantly 0, so what does that mean? A equals 0, so let's set this to 0. 0 equals 5 over 4 minus t plus 3 over 20 t squared. That probably will get you a method mark or accuracy mark once you complete this. So how can we make this easier for ourselves? Let's times out by 20. Multiply both sides by 20, so we get 0 equals 25 minus 20t plus 3t squared. Now I'm going to write this like this: 3t squared minus 20t plus 25, and you can just use a quadratic formula. But I will just, what would I do? I would factorise this, so 0 equals, I know that's going to be 3t, factors are 25, so it's got to be 5 and 5, that's it, minus 5t and minus 5, so we can see t equals 5 over 3 here, because 3t minus 5 has to equal 0, so 3t equals 5, t equals 5 over 3. or we've got t equals 5. But we know when t equals 5, v equals 0, so we don't really need to use this. And it does say the corresponding values of v when acceleration of p is 0. And now all we need to do now is substitute sub t equals 5 over 3 into our formula. V equals 1 over 20, then write 5 over 3 times 5 minus 5 over 3 squared. This needs to be seen to get your method mark, and then hopefully you find v equals 25 over 27, or 0.92 meters per second, minus 1. And that's your accuracy mark, and that's actually all of you can do that skill. Just need to expand correctly, factorise and use a quadratic formula, and that's not a bad question at all. Okay, let's have a look at this question. The particle P travels in a straight line. Now again, you can see this is variable acceleration because it changes with time. At time ts, the displacement of p from point O on the line is s. This is all key information they give you. We've got to use this at some point. And find the displacement when t equals 2. So from this information, what do we have? This is what we've got to look at. A equals 12t minus 4, right? A equals 12t minus 4. So remember, if we need to find displacement, we have to integrate and then integrate again. So the integral of A, which will give you v, will equal the integral of 12t minus 4, and that's with respect to the dt really, okay, in respect to dt. So v is going to give us, increase the power by 1, divide by the new power, so t squared, 12 over 2 is 6, minus 4t, and we can say plus c, or any constant plus a plus b. That's step 1. That's going to get us a method mark. Right. Now we need to integrate v to get s for displacement. Now we can't really find c here because of what information have we got? We've got t equals 1, s equals 2, and t equals 3, s equals 30. So we need time versus displacement. Alright, that's why we integrate again. So increase the power by 1, t cubed, divided by the new power, well 6 divided by 3 is going to be 2. Increase the power by 1, that's 2, minus 4 divided by 2 is 2. We know that's going to give us ct. Now we're going to get a new constant, and we've got to label it something else, any letter, so plus b, plus d, whatever. I'm just going to call it b. Okay, so we have this nice formula here. Plus b. So that gives us another method mark. Now we can substitute this bit of information into this formula. So t equals 1, s equals 2. What we're going to get, that's going to be 2 equals 2 times 1 cubed, that's 2, minus 2 plus t plus b, so that's t, that's c. Okay, now let's simplify that, so we get 2 equals c plus b. Right, so what do we have to do next? Think about the other bit of key information we have here that I've shown you and talked about before. T equals 3, S equals 30. We have to use all the information that they give you in a question. So let's sub that in. T equals 3, S equals 30. So 30 equals 3 cubed is 27. 27 times 2 is 54. Minus 9 times 2 is 18. Plus 3c plus b. Or little b I should write. But you get the picture. So what do we get here? 54 minus 18 is 36. Plus 3c plus b. So what are we going to get here? Let's move that up here. So we're going to get minus 6 equals 3c plus b. Now that is equation 2. I'm going to just make that capital B. So consistent. And we have 2 equals c plus b. That's equation 1. Now GCSE skill, we can see we have a simultaneous equation now. We're going to minus these terms together, so we're going to get minus 8 equals 2c. So c equals minus 4. Now we know c equals minus 4. B equals 6. And that's going to get us right here. With us doing this, is going to get our method mark. Accuracy here, accuracy, and an accuracy mark. We're almost there now. Really good work. So now we have, let's rewrite this as S equals 2t cubed minus 2t squared minus 4t plus 6. Find the displacement when t equals 2. So see that key information. So t equals 2, substitute that in, and you need to show this to get your marks. Just don't have to put it in your calculator. So if they see you doing this, it doesn't take much writing. Earn your method marks. Okay, you don't need to show the full working out, but show yourself substituting it in. And what do we get? This one you can use your calculator. S equals 6 meters. So that's a method mark here and an accuracy answer mark here. That should get you 8 out of 8. Now you can all do this. You've all got the skills to do this. Do watch this video again and try the questions from scratch, because we cannot learn just by watching. We learn by watching, doing and listening. Alright, well done. I hope that makes that clear. Alright, now that you're getting the hang of these skills, you can see that if a question like this, it's going to be a banker mark for you, which is really important. Get all the easy marks you can do. So we've got a sled here moving down a steep hill in a straight line. We've got time TS. The acceleration of the sled is a, and a equals this. Now when t equals 0, the sled is at rest, so that means t equals 0, v equals 0. Find the distance a sled travels in the first 10 seconds of its motion. Right, now we've got acceleration, we need displacement, so we need to integrate twice. Just earn some method marks, even if we're not sure what we need to do. So you will get a method mark by attempting to integrate this. Now you can, so integral of a equals v. Alright, now you can leave that outside the bracket and put it in later, the constant, but let's just do it all together so we don't make a mistake. That's over 500. Okay, so we're integrating that, minus t cubed over 500. And you can leave the 1 over 500 outside, but let's just do it that like this. So if we integrate, what do? We raise the power by 1, and that's in respect to dt. Let's do this properly. So that's going to give us t cubed divided by the new power. So you're dividing by 3, that means you're multiplying the bottom by 3, that's over 1500, minus raise the power by 1, divided by the new power, 500 over 4 is 125. Right, plus c. Now we know when t equals 0, v equals 0. And this is going to now give us our v. So when t equals 0, that's going to be 0, and c equals 0. So when t equals 0, v equals 0, c equals 0, there's no constant, makes it nice and easy. Right. Now I'm going to show you that you could have integrated this with leaving the 1 over 500 on the outside and just doing it like this. Sometimes this is easier as well. You can take this outside. And I want to show you this. dt. So integral a equals, let's do an arrow because it doesn't equal that yet. Alright, so v equals same thing, raise the power by 1. You're going to get t cubed 20 over 3. Right, with the 1 over 500 on the outside. So you can see you can do this as well. Minus t to the power 4 over 3. And as you can see, that's by the new power 4, so be careful there. And you can see this is the same answer as here, plus c. Okay, it's just good to know to make your life easier. Anyway, let's continue. So really we've got to integrate this again to get x. So the integral of v, let's get our notation good because I think that's our weak point. That's equals s. Okay, so we're gonna put the 1 over 500 on the outside. This is what we're integrating. T to the power 4 over 4 in respect to dt. So s is going to equal, raise the power by 1, divide by the new power, so that's over 12. That 20 is still going to be there. Let's not forget the 1 over 500. Minus, raised by the power, divide by the new power, so that's over 20. And that's plus c again, don't forget that. Now we know when t equals 0, v equals 0. But you write that there, t equals 0, v equals 0, so c equals 0. So s is essentially what we have here. Now, let's draw a line here and make that clear. S equals 1 over 500, 20t to the 4 over 12, minus t to the power 5 over 20. So we sub t equals 10 in here. So just show yourself subbing that in, because sometimes you do get a method mark for that. So 20 times 10 to the 4 over 12 minus 10 to the power 5 over 20. Put that in the bracket. And then you'll get s equals 70 over 3, which will get you the mark, or you can round to 3 significant figures. And there you go. Let's show you. That gives you the accuracy mark. Finding this, what I've written here, gives you the accuracy mark. Attempting to integrate, so even if you get it wrong, gives you a method mark. Finding this up here gives you a method mark. and attempting to integrate gets you a method mark. So actually, if you get to this bit here and rewrite this without the C, that gives you your method mark, right? Or you can write it down like how I've done here without the C, and you get the mark as well. So that's an easy 5 marks. Final question now. A says find the distance AB. We've got a car starts from point A. At time T after leaving A, the distance of car from A is S. Now we've got displacement in times of time, or distance in times in respect to time, 0 to 25. The car reaches point B when T equals 25. Find the distance AB. So that should be an easy 2 out of 2. We need to make it clear that we're going to be substituting T equals 25 in, right? Do show yourself doing that. So right, where's the pen? Alright, there it is. So T equals 25, just sub that into S equals 30 times 25 minus 0.5, 0.4 times 25 squared. That gets you your method mark, okay? So distance A to B must be 500 meters. That's part A done. Part B, it should show that the car travels with a constant acceleration and state the value of this acceleration. So we've got S, we've got displacement, we need to get acceleration. What do we need to do? You need to differentiate twice. Okay, so let's start with A. S equals 30 t minus 0.4 t squared. So ds dt equals v, which is going to equal 30 minus 0.8 t. Is differentiation, so no constant. Okay, I'm pretty sure that's going to get you a method mark, and it does. Now dv in respect to t is going to give you a, so that's just going to give you minus 0.8. Now can you see that's a constant with no t, so you've actually shown that because it's a straight value. So just make a statement, a is constant, as it does not depend on t. That's your answer mark, or accuracy mark right there. Now C says find the distance from A at which the runner and the car pass one in each other. So you've got a runner here, information about a runner and A. So let's go car from A is, let's just call that SA, equals 30t minus 0.4t squared. Just stating that gets you a method mark. Now the runner has constant acceleration. So what do we use? We're going to have constant acceleration. We have to use suvat. Okay, so it's mixing up your skills. So suvat, the most common one we use is ut plus a half at squared If you see that, you get a method mark. Initial speed is 2, a equals 0.1, and that's at time t equals 0. So SR for runner, or S2, is going to equal 2t plus a half times 0.1, that's going to be plus 0.05 t squared. Another method mark. So when R, the runner, this is A from which the runner and the car pass from one each other. So you have to think what you need to do here. Now, this information is hidden, but a runner passes through B when time equals 0. Okay. And he's running towards A. So in the context of this question, you've got A, you've got B, the runner is running this way. Now the car is going this way, and that's 500 meters. And so when do they cross each other? That's the question, what the question is asking. And you have to derive all this information from reading the question. Now the runner, lost track of my pen, he's going 2t plus 0.05 t squared that way, and the car is going at s equals 30t, let's call it SA, 30t minus 0.4 t squared, and that's SB. Now it equals 500 meters, so it would make sense that if you add, oh no, it's plus, sorry, 0.05 t. So if you add these together, when they combine to make 500, is when they will cross each other, because that's a total of 500 meters travelled. So really all we need to write is 30t minus 0.4 t squared plus 2t plus 0.05 t squared equals 500. Let's simplify that. Minus 0.35 t squared plus 32t equals 500. We want to set that to 0, so we're going to get 0.5 t squared minus 32t plus 500 equals 0. And something equivalent to that, that gives you your M1. Another method mark. Now you just need to solve this, and I would say use a quadratic formula. Use quadratic. And then you can see t will equal 20 seconds, and the other answer would be t equals 500 over 7, which equals 71.4, but it's not in the given range. Not in range. So it's not in this range, right? So the answer must be t equals 20. And that's your accuracy mark. Now there's one more thing we need to do. We get t equals 20 when they pass each other, so we need to sub t equals 20 into any formula, but let's do that into SA, and you'll get, if you sub that in, t equals 20 to SA, let's do that, where is SA? SA equals 30 times 20 minus 0.4 times 20 squared, going to be 160, so that equals 440 meters. So you need to state it, they cross 440 meters from A, and if it's from B, if you worked out from B, then you'd write the answer from B, and that's your final accuracy mark. Right, it's a bit of a long-winded one, but that is a bit more challenging and requires a lot of thinking and application skills, but I hope you got there. It's imperative that you go back to the start of this question, try this question again and see if you ace it, because you can, make a mistake with integration, resolving and solving, and you've got to get this skill perfect because you don't want to lose unnecessary method marks, and especially accuracy marks, which I've noticed a lot of us are losing.